Hi folks, welcome to today's stream. I'm Shahid and this is my first Twitch stream. So forgive me if there are any hiccups as I'm trying this out for the first time. Awesome. So let's see, how am I going to do this? I need to look at chat. So I'm just going to pop out that chat window from Twitch. I also need to make sure that the video is streaming, so I'm just going to pop that out too. Okay, then I need to watch out for my OBS. Awesome. Okay, so welcome to today's stream. Today we are gonna take a look at how we can deploy a production ready GraphQL Engine instance using Google Cloud Platform. What we're gonna be doing in a nutshell is to deploy Hasura as a Kubernetes application using Google Kubernetes Engine and configure all the required things like load balancer, HTTP, ingress rules and stuff like that. Also with HTTPS using Let's Encrypt. So after that, what we're going to be doing is we're going to look at how to deploy remote schemas and event triggers as, let's say, cloud functions, and we're going to look at how to do them as microservices on Kubernetes cluster as well, if we get time. So let's get started by going to docs. So we have a very quite exhaustive Kubernetes guide in the guide section, deploying section of the guides. If you go to the deployment guides, we can see that we have a Google Cloud Platform with Kubernetes Engine and Cloud SQL section. This is pretty exhaustive. It lists out all the steps required to get a Kubernetes cluster created and create a GraphQL Engine instance on that. So for that, we need to first have a Google Cloud project. That's a prerequisite. Here we are creating the Google Cloud project ourselves, but I already have a cloud project created. So let's just go to Google Cloud Console. So while we are at the Google Cloud Console, what I'm going to do is I'm going to see what my next command could be. So I'm going to be using a project called let's see. Okay, so let's see. Yeah, so I'm going to go use this project. I'm going to go to the Kubernetes cluster section, Kubernetes engine section of this. Yeah, so I'm going to go use this project. Okay. Super slow, Google. Yeah, so I don't have any Kubernetes clusters right now, and we are also going to use a Cloud SQL instance. So first of all, let's just get started by using gcloud CLI. I have it installed, and I'm going to create a Postgres instance. This is version 9.6 here. Let's see. So if I go and create it here, I'm going to use the project Hasura test. This is going to create a Google Cloud SQL instance. While that is being done, let's go to the Cloud SQL section, SQL, and see if our SQL thing is appearing. Okay, So it's starting to get the deployment process has started for the Cloud SQL instance. So this is our base here. This is what we are going to be using as our Postgres instance. This is a highly available managed Cloud SQL instance, Postgres instance. Just you get it on Google Cloud Platform. We don't need to worry about anything like managing the Postgres instance or even scaling it up. All of these things are taken care of. So while that is getting created, let's take a look at our next steps. So what we need to do after that is to set a password for our Postgres user. So we're going to be using this user with Kubernetes, with the GraphQL Engine instance that we're going to deploy on Kubernetes. And let's see, is that complete? It's still creating. I hope my font size is visible. Let me increase it a little bit. Yeah. So there are a couple of options to run Hasura on Google Cloud Platform. Since it's a Docker container, you can either choose to run it as a you can create a N1 you can create a Compute Engine instance and then install Docker on it and then start GraphQL Engine on that. You can also use the container OS that Google gives you out of the box on Compute Engine and give Hasura's Docker image there, as well as you can do that as well. But for the ease of use and for the ease of scalability, what we are going to do is we are going to use Kubernetes engine. We can just start a deployment and we can just scale it up, scale it down, and Kubernetes engine will even take care of scaling the instances down, instances up whenever required. So that's why you're doing Kubernetes right now. So again, if you don't want to use, okay, yeah, it's done. So we have our database Postgres server ready. So it's DB custom tier. This is the IP address for it. So the next step is to set a password. So let's see. I'm gonna go set a password. So I'm just gonna type some random password here. Test password 123. This is gonna set a password for the Cloud SQL user. So that's also done. Next step is to create a Kubernetes cluster. So we need to enable the Kubernetes engine APIs before we create the cluster. I have already done that for this project, so we don't need to do that right now. And then the next step is to create a Kubernetes cluster. Here I'm creating a cluster called Hasura KTS in the Asia South 1A zone with one node and inside the project Hasura test. So this is a single node Kubernetes cluster which is going to be inside in the Hasura, which is going to be inside at the Asia South 1A zone. So it just outputs a couple of warnings like something that you should worry about. Starting at 1.12, there are a lot of changes to the Kubernetes APIs. 1.10, new clusters will no longer get compute, RW, etc., etc., etc. If you use any of these features, please take a look at this and read them. So the cluster is being deployed. In the meanwhile, let's go to the Cloud SQL instance and just browse through here. So we can see that Hasura Postgres instance is created. So if we go inside that, let's just explore what other options we have such that we can scale this, etc. So we have a public IP address, we have an instance connection name here. We see that it's a 1 CPU, 3.75 GB memory, 10 GB SSD. So there's a enable high availability. So just starting with this configuration and moving to an HA setup is just as easy as clicking this button. Everything is taken care by Google Cloud Platform. So you can also see CPU utilization, storage usage, memory usage, read write operations, all these metrics here. You can also see the kind of connections that are open. We will see that the connection get created when we start Hasura on this. We have users here. So it will show the current users. There's only one user right now. We are going to use that user. We have databases. We are going to have just one database called Postgres. We are going to use this. You can take backups from this tab. You can create read replicas. You can also do other operations. So this will show a log of all the operation that has been done on this Postgres instance. So that's about the Cloud SQL Postgres. Let's take a look at the Kubernetes engine and see if our cluster is created. So if you have any questions in the meanwhile, you can always post that in the chat. So our cluster is still getting created. We are creating a one node cluster which has one CPU and 3.75 GB of RAM. So auto scale, okay, it looks like the cluster is created. Yeah, we have the cluster created. And Kubernetes, the gcloud CLI tool has already set my Kubernetes context onto the current cluster that is created. I have the kubectls already installed. If I do kubectl get nodes, I can see that I have one node which is ready, for which age is 47 seconds. So the next step would be to set up a Cloud SQL proxy. So this is a so this is something very specific to the way Google Cloud SQL and all works. The way we connect to Google Cloud SQL from our container running on Kubernetes is via a Cloud SQL proxy, which knows how to talk to the particular Postgres instance. So the process is a bit long. So let's just go through it. So what you need to do is to enable Cloud SQL admin API. So we can do that by going to our console and going to IAM and APIs and services and the dashboard. So here we'll find the APIs that are available on the Google Cloud Platform. We'll have to do, let's see, enable APIs and services. And once we are there, we can search for Cloud SQL So Cloud SQL admin API, this is the one we need to enable. So we will see if it is enabled already. So it's already enabled. If it is not enabled, you'll have an enable button here. You just have to click that button. Once that is enabled, we need to create a new service account. So to do that, we have to go to IAM and then service accounts. So at this on the service accounts tab, we need to create a new service account. We need to give Cloud SQL admin as the role, and then we need to create a key to download the JSON file. We are going to use this JSON file as the credentials to access the Postgres instance from within the Kubernetes cluster. I hope there is an easy way to do all these things in Google Cloud. I haven't found any. We just have to go through this. So I'm going to give it as my Hasura PGKTS. This is going to give it a name. After that, it is going to ask for role. So I'm going to give Cloud SQL admin, and then I'm going to download the I'm going to click the create key button, and I'm going to download the JSON file, key file for this. So it'll prompt to download, so I'm going to download this file, cc0 at the last. So the file has been downloaded. Now I have to create a Kubernetes secret with this JSON key file path. So I'll do that by copy pasting this command. So I'm creating a Kubernetes secret called Cloud SQL Instance Credentials, which is taking the data from this file, and the file has been downloaded to my downloads directory. So okay, looks like there is no autocomplete here, so I'm just gonna do this here, cd downloads. Okay, I have so many of these. So this is the one that we have just downloaded, so I'm going to copy this and paste it here. So home Shahid downloads, and this is the service account file. So this is going to create a Kubernetes secret called Cloud SQL Instance Credentials. Once we do that, we need to create another secret with a Postgres username and password. So if you remember, we had created a password earlier, which is test password 123. The username is Postgres. There's no change in that, so we are going to use this password, test password 123. So that secret is also created. So once we do that, we can create the Hasura deployment. So I'm just going to get this deployment file from the repo. So if you take a look at this deployment.yaml file, it's a app deployment file with Hasura GraphQL Engine image. It's v1.0.0 alpha 38, and it's going to take the Postgres username, password, etc. from the DB credentials that we just created. One thing that we need to do here, we need to give it the instance connection name, because there is a second container in this deployment, which is the Cloud SQL Proxy, which is going to talk to the Postgres instance running on Google Cloud. So to get the instance connection name, we can either execute a command or can also copy it from the dashboard here. For example, if we go to the SQL tab, we can see that if we go to the instance that we just created, on the dashboard for the instance, it will show the instance connection name. So we can copy this value from here and we can just paste it here. So we'll just remove this and we'll just paste it here. So we have the instance connection name added, and once we do that, I just have to create this deployment. So we can also get the instance connection name by executing this command, and once we add that, I'm just gonna create that deployment on Kubernetes. So we can check the status by executing kubectl get pods, and we'll see that container is getting created. So I'm gonna just watch on it every 2 seconds to see what the status is. Oops. Okay. It was error and it started running now. So both containers are running. If you wanna see the logs, kubectl get pods, we get the pod name here, kubectl logs deploy / Hasura -c GraphQL Engine. So we see that starting API server has started, and if you look at the Cloud SQL Proxy, okay, some connections are happening. So now if you go look at our database, let's see if we have something coming up in the connections tab of it. Let's see. Okay, looks like this is not for showing the connections, but You have not. Okay, this all looks fine. So we have GraphQL engine running, kubectl get pods, but we don't have a way to access it. So in Kubernetes, if you want to access something, what we do is we will create a service to expose that deployment. That's what we are going to do here. We are going to expose Hasura deployment using a load balancer on port 80, where the target port is 8080. So let's do that. So the service is exposed. Now we get kubectl get svc. We see that the load balancer is pending an external IP. So this is directly exposing Hasura using a load balancer on a public IP. So you have to always take care of adding a admin secret when we do this. Otherwise your data is vulnerable, like your data is out there in the open. So let me just do that. I'm going to add a new environment variable, Hasura GraphQL admin secret. Value is super secret password. Just a note, do not use this password in production. So I'm going to apply the deployment to update the environment variable. So it's updated, and if I look at the service again, I have an external IP allotted here. I'll copy this external IP, I go to my browser and I paste the IP, and I get redirected to console, and hopefully I get prompted. Oops, okay, let's see. Why didn't I get prompted? Okay, it's still recreating the pod because of the Cloud SQL takes some time to recreate the new pod and all. So by the time we go to another tab, maybe the new pod will come up. So let's just create a table. We call the table, let's see, we call the table profile ID integer auto increment, name is text. This is just for some demo. We choose ID as the primary key, and we create, let's just insert a couple of rows. I'm Shahid. Then we will insert Hasura, and we can see these rows are here, and we can query them using GraphQL. So profile ID and name, we get the ID and name. Awesome. So but this is not enough, right? Like we can't put an IP without HTTPS and all in a production instance, right? So we need to set up HTTPS on this, and typically on Kubernetes it is done using services are exposed using ingress controllers, and HTTPS, the typical way to do it is using cert manager, which will contact Let's Encrypt and provision an SSL certificate. So let's do that. For that, I am going to be referring the documentation that is available here. So huge shout out to our one of our clients who worked with us on setting this up. So this is the architecture that we are going to do, where we have a load balancer, we have Nginx sitting here, we have cert manager, it will load balance to Hasura. Hasura will talk to Postgres, which is a managed Postgres instance here, and then there could be event triggers and remote schemas. So this we have already done with Postgres. We have already deployed GraphQL Engine. Next, what we need to do is to create the Nginx ingress controller, right? So for that, I'll just clone this repository. Let me just clone that. So I'm just going to clone this into my current directory. Hasura K8 stack, and so first I need to create a namespace, config map, and deployments that are required for the Nginx ingress. So I'm going to cd into Nginx ingress, and if you look at the mandatory.yaml, what we have here is a namespace, then we have a config map, then we have another config map, again another config map, a service account, cluster role. These are all Kubernetes configuration required to deploy Nginx ingress. Let's not get into all these things. kubectl apply -f mandatory.yaml. So we'll create all these objects, and next step is to apply the cloud generic.yaml. Oopsie. Okay. So this says error when creating this is forbidden. Attempt to grant extra privileges. Okay, another one also failed. Let me take a look at the official documentation if they say something about this. Deployment. Okay. Yes, if you're using GK, you need to initialize your user as a cluster admin with the following command. Okay, let me do that. Let me initialize my user as a cluster admin. Basically, the cluster has RBAC enabled, and it is rejecting certain RBAC roles that are getting created in this YAML file. So let me just authorize my user as cluster admin. What this will do is it will create a cluster role binding called with the cluster admin role for the user, which is gcloud config get value account, which is the current user that I'm using right now. So now let's try to apply this again. Okay, so none of this was changed. So these two things which did not get created earlier got created now. And once we do that, I think we can safely go back to applying the cloud generic.yaml. So what's inside cloud generic.yaml? So this will have a load balancer configuration which will be used to bind to port 80 and port 443 for the Nginx deployment. So let's apply that also. So the namespace that we created right now, if you look at the mandatory.yaml file, the namespace is called ingress Nginx. So if you look at the pods in this namespace, ingress Nginx, we have one Nginx ingress controller running, and if you take a look at the services in this namespace, we have a load balancer. The external IP is pending though. So now that we have it ready, so we'll just have to use the external IP, but while that is getting done, we can create the ingress resource for Hasura. So instead of exposing Hasura over a load balancer dedicated for it, we will expose Hasura via Nginx. So if like we saw the architecture diagram, right now what we have done is Hasura is the load balancer is directly connecting to Hasura through the service, and traffic is getting directed to the pods here. Now what we are going to do, we have created Nginx. We are going to be using another load balancer to direct traffic. We'll delete the old load balancer after some time. Now we need to tell the Nginx ingress controller how to send traffic to the Hasura instance, right? So what we are going to do for that is we need to set up some domains. So we need to set a domain for the load balancer that Nginx got assigned right now. So right now it's called stack.hasura.app. So what I'm going to do is I'm going to call it gcp stack.hasura.app. So gcp stack.hasura.app. Okay, so we need to create this ingress resource, but before that, let me go ahead and map this external IP to that domain. So I need to log into our DNS server. Let me just do that on a different screen. I don't want anything sensitive to go out there in this Twitch stream. So let me just do that. So our IP is 35.200.169.231. If we go to this IP right now, what we're going to see is 404 not found. Nginx is telling us 404 not found. So I'm going to add Hasura to this. Okay, my email is, I'm gonna go log into my password manager to get the password for my DNS dashboard, and then okay, let me see. Yep. Okay, awesome. I need to get my device to enter the two-factor 2FA code to add the domain. Let's see, how do I do this? Okay, just give me a minute. Okay, I'm back. So I just need to enter my 2FA code. Lots of security. 3. Awesome. So the domain that we need to add is, let me take a look at that again. GCP stack.hasura.app. Okay, hasura.app. Where is it? Yeah. So DNS. Awesome. A record. GCP stack. Okay, so I have mapped the domain to this IP address. So if we go to this won't work right now. It will throw a connection not secure error because .app domains are by default HSTS enabled. It'll only be safe. It'll only work over HTTPS. Otherwise, browser will keep throwing this warning. So let's just quickly have HTTPS over it. So first we need to create this ingress object. So let's do that. So the ingress object is created, and once we have that, the next thing that we are going to deploy is cert manager. So before that, let's just check the status of the ingress. Let's see how it works. Okay, so we see that Hasura GCP, this domain is mapped to this IP address with these ports. Done. So now let's deploy cert manager. Cert manager is a Kubernetes add-on that automates contacting Let's Encrypt and getting HTTP certificate from Let's Encrypt for a domain. So the good good thing about this is all certificates and etc are stored as Kubernetes object, like secrets, config maps and all. And all we need to do is just create a bunch of Kubernetes resources. So again, oops, path namespace doesn't exist. Okay, that is strange. Then we'll create these CRDs. There are a lot of CRDs that Cert Manager uses. Then we create this cert manager.yaml file. So again, lot of cluster role bindings, jobs, cron jobs, deployment, lot of things. So again, so we are gonna have an error here which says, okay, so what I need to do is this is some Kubernetes version thing error. So I'm gonna run it with validate false, which should be just fine. Now, so by this time, if you look at the number of pods, kubectl get pods -- all namespaces. There are just a lot of pods, right? So I suggest we just let the cluster scale up one more node, just to make sure that just to make sure that there won't be any resource starvation issue here. So it's super easy to do. So it's already saying pods are unschedulable. So we just need to scale it up. So we go to the edit cluster thingy. We can also do it from the CLI. Let's just do it from the console here. Let's see. So we have a node pool here. I'm just going to make it 3 so that there are 3 nodes available for doing whatever we need to do. And then done, we'll just say save. So this is going to scale the cluster from the current node, which is right now, to 3 nodes. We will be able to schedule our pods right now. So GK also suggests how to set up auto scaling. So if we take a look at that, let's just take a look at how we can do auto scaling. It'll be pretty straightforward. We just need to enable some APIs and then click some buttons. That's all there is. It's important to note that whenever we deploy something, it should have things like resource limits and resource request per each pod. Then only auto scaling can detect when to scale up and to scale down. So enabling auto scaling is just passing a flag while you create the cluster. We can also do it after you create the cluster. So if we go back and take a look at our nodes, we have 3 nodes now, and all our pods should be schedulable right now. So let's just confirm it from this screen. If we go back to the main home screen, yeah, we have no notifications on the cluster. So where were we? We created cert manager.yaml. Okay, we need to now create an issuer. So we'll create a staging issuer first. The reason why we do this is Let's Encrypt has pretty strict rate limits. So if you mess up some configuration, it is likely that you will hit a rate limit and you will not be able to request for certificate again for a week or so. So what we have done is, when we created the ingress resource, so if we had noticed earlier, Hasura ingress, we had a line here saying the issuer is staging. Like we have commented the prod issuer, right? So now we are going to create that staging issuer, and then we are going to create the prod issuer, and then we are going to switch the ingress to use the prod issuer. So the issuers are get created. Let me just check if all the pods are running right now. So all pods are running right now. So we have cert manager running, Hasura is running, Nginx ingress is running, and all of the other things are Kube system which is run by Kubernetes engine on Google Cloud. So we have created the issuers. Now let's just edit the ingress. And what we need to do is to annotate, change this annotation to let's encrypt prod. So before we do that, let's just go and see what has happened here. Let's see. Yeah, so it's right now it's giving a self-signed certificate. And so let's just switch it out to let's encrypt prod issuer. Okay, before that, let's make sure that we have everything right. kubectl. Let's take a look at the cert manager documentation to see how we can verify a certificate has been issued or not. So getting started with documentation for the installation instructions. So tutorial, if you go to the tutorial, at the end of the tutorial we'll have quick start with cert manager and Nginx ingress. Okay, we have done that. Deploy, we have deployed a service. Now what we need to see is, okay, so this is the command that we need to see. So if you look at the certificates, there are no certificates right now. Let's see. So it looks like something we missed. Let me go back and look at the steps again. So as soon as cert manager starts running, okay, let's look at the kubectl get pods, all namespaces. We can see cert manager is running, but kubectl -n, cert manager. Let's take a look at the logs for this. Okay, so this looks fine, there are no errors here. Okay, let's take a look at this one right now. Okay, this one also looks fine, and let's take a look at our ingress resource again. Okay, so our ingress resource says gcp stack.hasura.app should have been created. Nope. Okay, let me do one thing. kubectl get pods, Hasura is running, but certificates are not getting generated. Awesome. So let me go back to the So here we have deployed the issuer first, then they have deployed the ingress instance. Maybe that order matters. So let's delete the ingress resource and create it again and see what happens. Okay, so what we're gonna do is, we're gonna go back to ingress. This is our ingress resource. So I'm gonna delete the ingress resource right now, kubectl delete ingress, and I'm gonna create it again, ingress.yaml, and now let's see what happens. Okay, awesome. So that was the step. We need to create the ingress resource after we have deployed cert manager. So that's a flaw that needs to be taken care of. I'll update the documentation accordingly, where we create the ingress after cert manager has been deployed. So the status says it's not ready yet. This is a secret. So if we describe the certificate, we will be able to get more information on this. So okay, it says certificate issued successfully the last second because it says ready true. So gcp stack dot hasura dot app, oops, gcp hyphen. Okay, so now it's again saying it's saying unknown issuer because the issuer will be the fake CA. Let's just verify that. More information, view certificate. Why can't I view certificate? Okay, looks like I can't view certificate. Anyway, the problem is, I'll show you what the problem is. So if I do curl -v, so we see that the certificate is issued by fake let's encrypt intermediate x1. This is because we have said in the ingress resource, we need to make sure everything is fine. We have used the staging API. All we need to do is to switch out the staging API to let's encrypt prod issuer. So this will contact the actual let's encrypt production instance to get the certificate. So we will take a look at certificates again, and let's see what happens. Okay, now I'm wondering if I need to delete and create the ingress resource again. Okay, so what we need to do is to delete the secret which is shown in the certificate to trigger the certificate generation again. So kubectl delete secret gcp stack hasura app tls. So secret is deleted. Now if you look at the now the new thing is getting created, describe certificates. So it's creating an order resource and it should work soon. Oops. Okay, so order is completed, certificate issued successfully. That means if we go and refresh our page here, we get HTTPS here. Now, now it's asking for the admin password also. So we can see that the connection is secure. Certificate is issued by Let's Encrypt. So super secret password, if I remember it correctly. So we can look at our profile that was created and our APIs are working, and we have HTTPS on our GraphQL APIs here. So what we have done so far is to set up Hasura on a Kubernetes cluster, and we can see by looking at the workloads here that Hasura is running on a Kubernetes cluster. It is contacting a Cloud SQL Postgres instance again on Kubernetes on the Google Cloud platform, and we can see all of these components are running to support the Hasura deployment. So one thing that we might see here is we had created a load balancer earlier. So kubectl get svc will show a load balancer which was created earlier, which will again take us to the console. We don't need this anymore because right now our traffic goes through ingress, so we can delete this load balancer. Delete svc, which is called Hasura. So we don't need that IP address anymore. We don't need the load balancer anymore. So if we look at kubectl get svc hyphen hyphen all namespaces, we should see that this is the IP that we're using right now, and kubectl get ingress will tell us that this is the domain that we have configured with this IP address. These IP addresses are the same. So this is the only external IP address on the cluster. That means this is the only entry point to the cluster. And scaling Hasura to handle multiple requests is as easy as scaling the deployment. So if we look at the deployment right now, we have one instance of Hasura running. We can easily scale the deployment. Kubectl scale deploy / Hasura hyphen replicas. 1 second, let's see. Hyphen replicas, let's say 5. So this will scale Hasura to 5. So we have desired, current, and up to date all are 5, and 5 are available. So if you look at this kubectl get pods, we can see that 5 pods are running right now, and that whenever we make a query, the request might go to any one of the pod. Okay, I have an error here. Oh, what? Okay. Oops, service temporarily unavailable. So the mistake I made is I deleted the service object saying that we don't need this anymore. So we need the service object for the ingress controller to direct traffic to the Kubernetes pod. For example, this is the backend. The backend is defined as Hasura, service name is Hasura port 80, but I deleted the service. What I should have actually done is change the type load balancer to type cluster IP. I should have done that. So let's just create that again. Let's just remove the type load balancer and make it cluster IP. Now service Hasura is exposed, and we should be able to use this console, and then whenever we make a new request, it should go to the any one of the instances. So this is the endpoint that we have right now. This is the admin secret. So we can also make curl request with admin secret. So admin secret is just a way to, it's like a database password, and you should not be sharing this or putting this in the client side. You should configure authentication and access control to control access to data. You can go to the docs and look at this page and learn all about it. If you are deploying something like a public API, what you can do is set something called where you have only an admin who adds data, and anybody and reading data is public or something like that. You can set unauthorized role. So you can set something called unauthorized role, where you can define a role on which permissions can be defined, and whenever the admin secret is missing, this role will be used. So super secret password, and this my URL is this, and I'm gonna make the query profile ID and name. So I'm getting the response here. So this is my GraphQL API. The same API can be used from a client application using Apollo client or any other HTTP/GraphQL clients that you have. So let's see. So scaling is that easy, and if you have to, let's refresh this and see. We can see that we can see all the workloads here. We have 5 Hasura instances running, and if you look at the applications, I think it'll show, yeah, it'll let you deploy application in the marketplace. Okay, so now scaling Postgres is also pretty straightforward for an high availability setup. Let's take a look at that. So if you enable auto scaling on Kubernetes, that should be enough. And for high availability, you can also enable multi-regional clusters or across the zone clusters. So if you look at Postgres, there is a button called enable high availability, and I think clicking this will, so it will change it from a single zone to high availability. This instance will automatically fail over and only recommended for production instances, and increases your cost. So let's just check it out, enable it and check it out. And if you look at the active connections right now, we can see Hasura keeps, so we have 5 connections on the 5 Hasura instances right now. As the number of queries instances increases, one Hasura instance might use up more than 1 connection per instance. So let's see. So we have enabled high availability for this instances being updated. Let's go to the Kubernetes engine again and take a look at how we can enable high availability for the Kubernetes cluster. So let's take a look at it. Okay, so if you look at this configuration here, so all we need to do is to enable this additional zones. So we need, so that we, even if one zone has an issue, we have failover on the other zones, and we need to just enable automatic node repairs, automatic node upgrades, and we need to enable auto scaling. Okay, somehow, which is disabled here, we should be able to do this somehow. And that's all we need to do, enable the auto scaling. We can do it from the CLI also. So I hope that concludes today's stream, and I hope you all were able to learn something out of today's stream. We will continue with the second part of the stream sometime later, where we will be deploying remote schema and event triggers as Google Cloud functions. Stay tuned for that. Meanwhile, just ping us on Discord if you have any questions. And till then, I'm Shahid. I'm an engineer at Hasura. I maintain GraphQL Engine. See you next time. Bye. It's good night here. It should be good morning at your place, wherever you are. Have a nice day. Good night.